Okay, write an equation of a line that passes through the point 2, 8 and negative 4, 12. Let's start with the slope. Subtract the y's in the numerator, that's the rise. Subtract the x's in the denominator, that's the run. 12 take away 8 are the two y's subtracted. We want to subtract the x's in the same order. Negative 4 take away 2. So the numerator is a 4. Be careful, the denominator is a negative 6. But don't leave it like that. Reduce it to negative 2/3. That's your slope. Now we need to take one of these points. Let's take 2, 8 together with the slope being negative 2/3, and let's plug in the y equals mx plus b, because we already know part of the answer. We just need to know what the b is. So we'll take the x, the y, and the m, plug them in, and we'll figure out what the b is. The y is 8. That's supposed to equal to negative 2/3 of the x, which is 2, and then we add on the b. Let's see, it's easiest actually to multiply through by 3, just to get rid of the fractions. Just take the whole equation times 3. What we end up with is a 24 equals negative 4 plus 3b. When we multiply the negative 2/3 times 2 times the 3's cancel out and you get a negative 4. So that's much easier to deal with. We have a 28 when we add the 4 over. So 24 plus the 4 is the 28. That's supposed to be equal to 3b, and then we divide by 3. So we get the value of 28/3 as b. And so that is your answer to the question. That's the line that goes through those 2 points. Okay, now write an equation of a vertical line that goes through these 2 points. A vertical line has equation x equals some constant, because a vertical line lets the y be anything you want it to be, but the x is stuck at some constant. They give you 2 points, negative 6, negative 10, and negative 6, 12. If you were to plot those 2 points, what would happen would be you'd be at negative 6, negative 10, and then also at negative 6, 12, somewhere up here. That vertical line is the line x equals negative 6. Okay. If you want to write the equation of a line that's parallel to another line, we know that parallel lines have the same slope. They're sloping in the same manner makes them parallel, that the fact that they'll never intersect. So if this guy has a slope of 1/2, then yours will also have a slope of 1/2. Now it's about this point, 6 and 4. We'll do the same thing we just did. Y equals mx plus b. We already know part of the answer. We just have to figure out the b. Take this y, x, and m, plug them in. 4 is half of 6 plus b. Half of 6 is 3. So subtract the 3, and b is 1. So there's your equation of that line. Okay. Alright, great. This switches gears and talks about a system of equations, two lines basically, and we're asked about, is it consistent Is it inconsistent or is it dependent? Okay, let me just describe what those words mean. A system of equations is called consistent if there is a solution. Okay, so it's very possible that there could be no solution. And that system is called inconsistent. So, consistent and inconsistent. Dependent. A dependent solution, a system is called dependent when basically you really don't have a system. Ultimately, you have the equation of one line, and then you have that same equation just written in a different manner, or maybe doubled. 2y is 2mx plus 2b. So it looks like you have two equations, but you really only have one equation, and your answer is dependent, meaning that you only get one line, and your x and your y relationship is that they are dependent. Graphically, if you have two parallel lines, they'll never intersect, and so that is inconsistent. If you have two lines that intersect, that's called consistent. And this third situation is both consistent and dependent, I guess. There is a solution. If I graph the one line and I graph the other one on top of it, it's the same line. So there is a solution. So it is, on the one hand, consistent, but on the other hand, it's also dependent, because you only have one line there. So with this situation here, let's put them in the same format, either ax plus by equals c, or y equals mx plus b. Let's go with the ax, usually with a system you want it in this form. Ax plus by equals c. So let's say negative 6x plus 3y equals negative 10. Negative 10x plus 5y equals 14. So we can for sure say that they're not dependent. It's not possible to multiply one equation by a number and get the other one. They're not. Well, they might be parallel. Let's see. What is the slope? Yeah, I think they're parallel. Well, let's see. So if I take and find the slope of the one and find the slope of the other, I think they get to be the same slope. Yeah. Let's just do that real quick. We don't have to solve the systems. They just want to know what type of system it is. So yeah. So when you're in ax plus by equals c format, the slope is negative a over b. You'd have to solve for, like, y equals mx plus b. You have to solve for y. You'd have to subtract the ax over and then divide by the b, and minus ab would be the number that's in front of x. So this is a way to quickly get the slope when you're in ax plus by equals c form. So the slope of the one line is the opposite of 6 over 3. The slope of the other line is the opposite of, the opposite of negative 6 over 3. This guy is the opposite of negative 10 over 5. They both have a slope of 2. So we have this situation where we have parallel lines. when you have exact copy, it looks like they have the same slope, but what's different about this is that on the right hand side, these numbers won't be the same, so or won't be one multiple of the other, and so that's why we have for this question the fact that the lines are inconsistent.